Hi everyone, good day. My name is Nitin Raja. My matrix number is CE190043. So before I start my presentation, I would like to say that I am sorry my webcam is not working, so I have to present myself in this way. So today I would like to present about exercise 9, which is AC voltage measurement using oscilloscope. So let's look into activity 1. So figure 9.1 shows a series circuit with a resistor and a variable resistor which are connected in series with an AC supply. So this simulation circuit had been completed according to figure 9.1 using Proteus software with supply of 14.6 volt with the frequency of 50 Hz, where R1 is 100 ohm and variable resistor is 1 kilo ohm. So the circuit has been simulated and the voltage of AC supply, which is variable resistor 1 and resistor 1, has been recorded by using the oscilloscope, and the output graph had been produced. So let's we look into the simulation diagram. So this is the simulation diagram connected to the which is connected to the oscilloscope. So as you can see, the resistor 1 and variable resistor 1 are all connected in series with the AC supply, and the oscilloscope is connected to the uh, AC supply, resistor 1 and variable resistor 1, in order to capture the output graph. So without wasting much time, let's jump straight into the simulation. So as you can see, this is the simulation circuit that we have produced using Proteus software. So let's we run this simulation and have a look at the output graph. So as you can see, this is the output graph that had been produced. So in channel A, AC supply has been connected. So resistor 1 has been connected to channel B, and the variable resistor 1 had been connected to channel C. So as you can see, uh, the the graph produced are all almost identical, where at the channel C, which is a variable resistor 1, the graph produced is inverse compared to the graph channel A and channel B. So this is the result that we have obtained from this simulation. As you can see, this is the VAC supply graph from Proteus software. So this is a VVR1, so which is a voltage for variable resistor 1 supply graph from the Proteus software, and the resistor 1 supply graph from this Proteus software. So let's we look into the values. So as you can see, for the VAC supply graph, so we have produced peak to peak voltage which is around 21.62 watt. The period of the wave cycle is 20 millisecond, and the VRMS based on this graph is 7.64 watt. So the frequency of this waveform is 50 Hz. So for variable resistor voltage graph, so we can say that the voltage peak to peak we obtained 19.66 watt. The period is 20 millisecond. The VRMS that we have obtained based on the graph is 6.95 watt, and the frequency is 50 Hz. So this is the graph that we have obtained, we have drawn, and for the resistor 1 voltage. So the peak to peak voltage value that we have produced is 17.9 volt. The period is 20 millisecond, and the VRMS is 6.33 volt, and the frequency is 50 Hz. So that's all from me. So I would like to pass this presentation to my teammate. Thank you.
Assalamualaikum, my name is Nik Nur Akilah. Now we continue on activity 2. For activity 2, we're gonna adjust the VR1 to 200 ohm and simulate and record the voltage across the VR1 and R2 by using the oscilloscope. Okay, so now we're gonna put all the equipment for the simulation. We start with the AC voltage for the power supply, and we also put the resistor, the 100 ohm resistor, and the variable resistor, 200 ohm variable resistor. Then we adjust the AC voltage to 14.6 volt and 50 Hz frequency. And next we put the oscilloscope to find the waveform. A channel will go to the R1 and the B channel will go to the VR1 to find the voltage waveform. Next we will try to run the circuit and we can see the waveform here. I will put the T2 on the peak voltage waveform and we can see the table below. It shows the channel A and the channel B waveform value. And next we put the T1 to the minimum peak and we can see the T2 minus T1 is the V peak to peak, and next is we put the T1 and T2 to the minimum value to find the period, and that's how we get the value. Thank you.